Once again back to my YouTube channel Csir. Today I am going to discuss another problem from CSIR Net Mathematics Science question paper from the year December 2025. The problem is from part B. The problem is from linear algebra. Problem number is 28. The problem is given as let A be a 3 cross 3 matrix over complex number with the trace value is 1 and determinant value is also 1. Suppose further that one of the eigenvalue of A is 1. We have to check which of the following statement is necessarily true. The characteristic polynomial of A has repeated roots. Second option, eigenvalue of A as absolute 1. Third one, A does not have any value which is eigenvalue on the imaginary axis. The fourth one, A square is the identity matrix. Since the problem is from part B, only one option will be the correct option. Solution: A, which is 3 cross 3 matrix. This A must have 3 eigenvalue. One of the eigenvalue lambda 1, second eigenvalue lambda 2, third eigenvalue lambda 3. We know very well sum of the diagonal which is equal to sum of the eigenvalue which is equal to trace which is equal to sum of the eigenvalue, and also determinant must be equal to product of the eigenvalue. Also in the problem it is given that one of the eigenvalue is 1. One of the eigenvalue is 1. Take lambda 1 which is equal to 1. Trace is given as 1. 1 plus lambda 2 plus lambda 3 which is equal to lambda 2 plus lambda 3 equal to 0. Product of the eigenvalue which is equal to determinant. Determinant also 1. 1 equal to 1 into lambda 2 into lambda 3 which is equal to lambda 2 lambda 3 which is equal to 1. Lambda 2 plus lambda 3 is 0. Lambda 2 into lambda 3 equal to 1. What is lambda 2 minus lambda 3? The whole square. Lambda 2 plus lambda 3 whole square minus 4 times lambda 2 lambda 3. Lambda 2 plus lambda 3 is 0 minus 4 into 1 which is equal to minus 4. What is lambda 2 minus lambda 3 which is equal to plus or minus I2. Lambda 2 plus lambda 3 is 0. Lambda 2 minus lambda 3 is 2i. If you add 2 lambda 2 equal to 2i, lambda 2 is I. One of the eigenvalues is 1, second eigenvalue is I. Since lambda 3 plus lambda 2 is 0, lambda 3 is minus lambda 2 minus I. Therefore eigenvalues are 1 I minus I. Now check the option. First option, the characteristic polynomial of A has repeated roots, but we are getting one of the eigenvalue is 1, second one is I, third one is minus I. Option E. First option wrong option, not repeated roots. Second option, every eigenvalue of A has absolute value is 1. Now find the absolute value for every eigenvalue of A as absolute value 1. Absolute value is modulus of 1 1, modulus of I 1, modulus of minus I 1. All the values of eigenvalues of A with the modulus, that is absolute value, is 1 for modulus 1, modulus I is also 1, modulus of minus I is also 1. For this problem, option 2 is the correct option, and also I am going to check the third one. A does not have any eigenvalue on the imaginary axis, but we are getting plus I minus I. Out of the three values, I and minus I appears, which is imaginary value. Third option is the wrong option. First one already wrong, third one wrong. A square is the identity matrix. Option 4, lambda value for eigenvalue of A, lambda value is 1 I minus I. For A square, if the lambda is eigenvalue for A, lambda square is eigenvalue for A square. 1 square I square minus I square. 1 I square is minus 1, it is plus 1. This is the eigenvalue for A square. Normally for identity matrix, eigenvalue for A is, if A is I, A square is also I. A square I means eigenvalue must be 1 1 1, but we are getting 1 minus 1 1, not 1 1 1. Therefore option 4 is also wrong option. For this problem, only the second option is the correct option. Since it's from part B, only one option may be the correct one. I will upload more problems from CSIR Net Mathematical Science question paper. Subscribe my channel, share my channel to your friend, like my channel. Thank you.